In this video, we'll talk about special factoring. And this special factoring involves learning some formulas. But before I show you the formulas, I want you to show how you can get to them. So let's say we have this example where we have to factor x squared minus 1. And we learned in this class to factor quadratic expressions. While this quadratic expression maybe is not complete as an ax squared plus bx plus c, but I can see that this can be written x squared plus 0x minus 1, right? The term in x is 0. So let's look for two numbers that have the sum 0 and product negative 1. So if we check the negative 1, it's 1 times negative 1 and negative 1 times 1, which is the same, right? So 1 times negative 1 is negative 1, 1 plus negative 1 is 0. That means the factors of x squared minus 1 are x plus 1, x minus 1. Let's try a couple more. Let's say we want to factor x squared minus 4. So again, we are looking for two numbers that have the sum 0, right? Because the term in x is not there. And the product is negative 4. So the two numbers that satisfy this are negative 2 and 2, or 2, negative 2. So the factors are x plus 2, x minus 2. And let's do one more. X squared minus, let's say, 25. So s equals 0, product equals negative 25. The numbers are 5 and negative 5. So x plus 5, x minus 5. And I bet by now you figure out a pattern. If I have a squared minus b squared, right? If I have a perfect square minus another perfect square, the factors are a plus b, a minus b. So this is our first formula for a special factoring. So now you don't have to go through all the sum and product. If I give you a problem like x to the second minus 25y to the second, you can immediately say, well, it looks like x everything to the second minus 5y everything to the second. So this way we figure out that our a and b are x and 5y. So x plus 5y, x minus 5y right away. All right, now let's take a look at another situation. What if we have x squared plus 1 and we want to factor it? So following the same process, I'm looking for two numbers that have the sum 0 and the product 1. So the two numbers that have product 1 are 1 and 1. 1 plus 1 is never 0. So what does that mean? This means it's prime. Let's try another one. Let's try x squared plus 4. So again, sum is 0 and product is 4. So the two numbers that give us 4 are 1 and 4 and 2 and 2. And of course, the negatives. Let's put the negative 1, negative 4 and negative 2, negative 2. But if we add any of these pairs, we don't get 0. So again, prime. What does that mean? It means that a squared plus b squared, it's prime. So we don't have a formula like we had this one, right? So an a squared plus b squared, it's prime. All right, now let's take a look at another situation. Let's say 5. We have x squared plus 2x plus 1. So again, I'm going to try to factor using sum and product. The two numbers are 1, 1. So the factors are x plus 1, or I can write x plus 1 squared. Let me try another. X squared plus 4x plus 4. So again, sum is 4, product is 4. The two numbers are 2 and 2. So x plus 2 times x plus 2, which makes it x plus 2 squared. And one more. X squared plus 8x plus 16. Again, the sum is 8, the product is 16, the numbers are 4 and 4, so we get x plus 4 squared. So again, I hope you got the idea. If I have a squared plus, then I have a perfect square as well, right? The first term, it's a perfect square. The last term, it's a perfect square. The first term, it's perfect square. Last term, perfect square. If that happens, and in the middle, we have twice the product of a and b, then this can be written a plus b squared right away. So we don't have to do all the sum and product, right? So if here I have x and 1, twice x times 1 is 2x. This is x and 2, so twice that, it's 4. X and 4, twice that, it's 8x. So basically, this is my new formula. And for example, if I have x squared plus 16x plus 64, well, this is x squared, this is 8 squared, and in the middle I have 2 times x times 8. So because of that, we get x plus 8 squared. So it's very important that this term is double the other two, because it can happen that we have a perfect square here, and in the middle not double, so then we cannot use the formula. This formula works also if we have minus. So x squared minus, let's say 4x plus 4. Well, sum is -4 and product is 4. So the two numbers are -2, -2. So we get x minus 2 times x minus 2, which is x minus 2 squared. So in other words, the formula that we just wrote there, it's a squared minus 2ab plus b squared, is going to produce an a minus b squared. So now that you know these formulas, you don't have to do sum and product for this type of problems. And let's see sum and difference of cubes. So here I'm just going to give you the formulas. A cubed plus b cubed is a plus b times a squared minus ab plus b squared. If you multiply everything, you're going to get exactly a squared plus b squared. And a cubed plus b cubed, and a cubed minus b cubed, it's a minus b times a squared plus ab plus b squared. Notice that in the middle here we don't have plus 2ab like we had in the previous one, it's just ab. So in other words, let's say problem 9, if we have x cubed plus 8, well, I'm going to write it x everything cubed plus 2 everything cubed, just so that I emphasize that a it's x and b is 2. So we have now x plus 2 times x squared minus the product of these two, 2x plus b squared, that's 4. And another one, 27x cubed minus 64y to the third. So again, I want to show what are my, what is cubed minus what is cubed, right? What is my a and b? So in this case, we're going to have 3x cubed is 27x cubed, and then 4y is cubed. So in other words, a and b are 3x and 4y, so 3x minus 4y times 3x squared, that's 9x squared, plus a times b, that's 12xy, and then plus 4y squared, right? 4y squared means 4y times 4y, which is 16y squared. So plus 16y squared. And this is the final answer. So we have learned a few formulas, right? Difference of cubes, sum of cubes, perfect trinomial, perfect square trinomial, another perfect square trinomial, and difference of two squares. There is no sum of two squares. I hope this helps.